Now I want to show you how to set up and actually run DynuStudio program properly. To begin, we first open the DTA simulation setup dialog box, which can be found either on the modeling drop-down menu bar or on the quick launch toolbar indicated by the big red delta symbol. On the DTA setup dialog box, a number of settings need to be configured. First of all, we need to decide what type of a domain data to use, which can be vehicle file, OD domain matrix, or vehicle and the path file. To simplify for this demonstration, we will be using the OD domain matrix. Once selected, then we can proceed to open the domain setup dialog box and to select the corresponding OD tables. Those OD tables are the matrices prepared previously in DynuStudio binary format. The purpose of a domain setup is to export the binary data to the standard text file format so that the DynuStudio can recognize. In this process, user has an option to factor up or down the domain table, or to extract the partial domain by certain time intervals. Once we have selected the correct tables for each mode, we can click the Start button to generate the OD tables for DynuStudio. When finished, a report will be generated to indicate the number of trips produced for each time interval by each mode. So in this case, we have a total amount of trips is, for example, is about 2.1 million for the SOV and 270,000 for truck and 450,000 for HOV, and also indicate what is the intrazonal percentage for each mode. In this case, we have 6% for SOV and 9.8% for truck and 9.2% for HOV. Then we can close the report. Once the domain is set up, we need to decide which assignment method to use, which can be either one-shot or UE consistent method. For one-shot method, we also need to set the user class to pre-trip information class. Similarly, for UE consistent method, we need to set the user class to user equivalent class. That's the number 3 in this case. When we use the UE consistent method, we also need to set the maximum number of iterations to run in order to reach a reasonable convergence. The next important setting is the simulation horizon, which determines how many minutes a DTA model is simulating in each iteration. Certainly, the longer the horizon is, the longer the runtime will be needed. For a large regional network with several millions of vehicles, the runtime can take multiple hours or even multiple days, depending on the size of the model. For this demonstration, we will be using a very short horizon, such as 30 minutes, so we can get the results quickly. When we change the horizon, we also need to change the simulation statistic period in order to generate a meaningful statistical summary. This number is usually the same as the horizon. We can use default values for many of the settings shown in the middle section of the dialog box. However, we do need to select a valid traffic flow model table to be used for every assignment. In addition, we also need to confirm where we want to include the network scenario settings in the assignment. In this case, we have a tolling, incidence, and a ramp metering. They are already coded in the network, but we can decide whether we want to include them in the assignment or not. Lastly, we also need to confirm whether we want the DynuStudio to generate link-based performance measures or not. That can include many outputs, such as link queue, link speed, link density, and total flows. If those outputs are generated, DynuStudio will be able to display them for further analysis. DynuStudio also includes more than 60 also advanced parameters that allow users to control how a simulation should work precisely. In most cases, we just use the default values. There is one parameter that we often change, is the number of threads we will be using for a simulation. This allows you to maximize the computing power. If your machine has multiple CPU cores, in this case, I want to increase the number of threads from 4 to 8, for instance, since my machine has a quad CPU cores. So once you change the value, you need to click the update button. Then click the save button to confirm the modifications. So now it shows we will be using 8 threads for this assignment. Before we launch DynuStudio, One more thing to check is to make sure we are using the correct Dynasty executable version as identified by the file path. If everything were configured correctly, we can click the Run button here, and everything in the Dynasty should start automatically. By indicating the run status. Dynasty first performs mesoscopic simulation for every vehicles and calculate the aggregated link-based performance measures. Then, to build time-dependent utility path for each vehicle and assign trips to the path. This coupled simulation assignment steps will repeat in each iteration until either the maximum number of iterations or the preset convergence target is reached, whichever comes first. So when Dynasty finished, DynuStudio will back in action to import output vehicle trajectory and the link-based performance measures for analysis and visualization, which will be discussed in the next session. When it finished, a report will be generated that shows some high-level summary of the simulation results. Tells you how many threads we are using, and the horizon, the number of iterations, and the total vehicles we are simulating, and also the total runtime, and also the convergence measures in each iteration. Since we are only run 3 iterations, you can see with the convergence the R relative gap in this case is all 0 because we have a very small amount of trips. And they also showing the unfinished number of trips. You can see this number is decreasing. If we run more iterations, then the unfinished trips should be 0.